In this video, I'd like to introduce you to extraneous solutions, which is basically a fancy word for wrong answers. Usually they're presented as something to discard on your way to solving a problem, but I'd like to intuitively show you why they even show up at all. Oh, and watch closely for my sister's stamps, which might sneak up onto the screen in the middle of our math. There's one. Okay, so first we're going to look at this equation. The square root of x plus 8 minus 6 is equal to x, right? You solve this like any other equation. You just do the same thing to both sides until you get x by itself. So we get square root of x plus 8 is equal to x plus 6. We added 6 to both sides. Square it, you get x plus 8 is equal to, let's see, x squared plus, you double that, 12x plus 36. We squared it to undo that square root. Okay, from here, we need to take away an x and take away an 8 to get 0 on this side and everything else on the other side. So I get 0 is equal to x squared, 12x minus x gives us 11x, and then 36 minus 8 gives us 28. So from here, we can just factor this, which basically turns it into two linear factors, x plus something and x plus another thing, where the numbers add to 11 and multiply to 28. Well, that's going to be 4 and 7. 4 plus 7 is 11, and 4 times 7 is 28. And this is all equal to 0. Now, because these are multiplied by each other and this whole thing equals 0, that means either this equals 0 or this equals 0, right? So we say that x plus 4 equals 0 or x plus 7 equals 0. And then we get x is equal to negative 4 and x is equal to negative 7. So these are solutions to the problem. Sorry for my creaky chair. But from here, we're just going to plug them back in to our original equation like any good math student would do, right? It's a great way to let us know if we're doing the right answer. Starting with x is equal to negative 4. This is going to give us the square root of negative 4 plus 8 minus 6 is equal to x, which is negative 4. Negative 4 plus 8, that gives us 4. So we have the square root of 4 minus 6 is equal to negative 4. 2 minus 6 is equal to negative 4. Negative 4 is equal to negative 4. Awesome. That worked out. I mean, it'd be really concerning if it didn't. X is equal to negative 7. Plug this in again. Negative 7 plus 8. And we're taking the square root of all of that. Minus 6 is equal to negative 7, right? Negative 7 plus 8, that gives us 1, right? So we have the square root of 1 minus 6 is equal to negative 7. And that's obviously 1. 1 minus 6 is equal to negative 7. And finally, we get negative 5 is equal to negative 7. Speaking of really concerning from earlier, we solved this through a perfectly valid process, yet for some reason, we get negative 5 is equal to negative 7, which is obviously not true. So negative 7 isn't a solution, despite the fact we solved the equation exactly how we were supposed to, whereas negative 4 was a solution. So something really weird here is going on. Negative 7 is called the extraneous solution. And usually in school, you're just told, okay, this doesn't work because we checked it, so you just ignore it, say negative 4 is the solution, and move on. But throughout the rest of this video, I like to show exactly where this negative 7 comes from through graphing. Let's graph our equation in order to make sense of what's actually going on with the extra solution. So we're going to graph square root of x plus 8 minus 6 is equal to x. As you can see, that doesn't really help. What Desmos does is it solves this equation and gets x is equal to negative 4, and then just graphs it, which gives you a vertical bar right at x is equal to negative 4. What we really want to do is treat it like a system of equations. If we have x plus 3 is equal to 2x, we don't just want a vertical bar at the solution. We want to graph each side and see how both sides change and where they're equal, right? And you look at the point where both sides intersect, and that gives you the solution. And it's a lot more visually helpful. So let's start with graphing the square root side. It's going to be some variation of the basic square root of x function. So let's look at this first and see if we can find some patterns. First off, you're going to notice it looks a lot like the x squared parabola, like this, only it's kind of flipped on its side and half of it's missing. Why is half of it missing? Well, that half belongs to the negative square root of x. With a parabola that is the x squared version, you can have 3 times 3 gives you 9, or negative 3 times negative 3 also gives you 9. So then you have that nice symmetry. However, when you're flipping it to give the inverse function, the square root of x, we only want one output. We want it to still be a function. So therefore, we just say the square root of 9 is 3, not negative 3. The square root of 16 is 4, not negative 4. Because of that, we actually end up losing half of the parabola. Keep this in the back of your head as it's important very soon. So we're going to graph the full equation now, both sides. So we have the square root of x plus 8, adding moves it to the left, then subtract 6, that moves it down, and we're saying that this side of the equation is equal to x. So there's your y equals x line. As you can see, the points where the two sides of the equation are equal is at -4, -4, meaning that each side of the equation is equal to -4, and the solution that makes them equal to -4 is -4, right? Those two sides have to be, the total equation and the input have to be equal just because we're using y equals x, right? Airplane just flew by. Wonder where that came from. So where is the -7? Where is our extra solution? Well, suppose we added the other half of the parabola back. That would be the negative square root of x plus 8 minus 6. And look at this. The parabola curves back around and hits the line a second time at, you guessed it, -7, -7. So the extraneous solution actually comes from the hidden, ignored second half of the parabola, the bottom branch, coming back around and hitting the line. So that's the geometric interpretation for extraneous solutions. Whenever you have a radical equation and you solve it and you get this solution that doesn't make sense when you plug it back in, it's actually because you have the second branch of the parabola hitting the other side of the equation. But when you plug it back in, you end up, it ends up not working, right? So we can see how this works visually, but why does this solution, this -7, this extraneous solution, why does this even show up in our algebra at all when it's not a valid solution? Well, we're going to go back to paper and figure it out. So here I have graphed a much simpler equation so we can understand what's going on. We have the square root of x is equal to -4. If we square both sides, we get x is equal to 16. However, if we graph this in Desmos, we would see that this is our graph of the square root of x, and at 16, it's not intercepting this bottom line, which is y equals -4. We have to have the second branch of the square root function come down here, the negative square root of x, to actually intercept our red line. Similarly, if we were to check this using algebra, we would get that the square root of 16, that's equal to 4, and it's not equal to -4. So what's going on here? Well, if we look at -4 times -4, we can see that that equals 16, right? So -4 squared is 16. However, if we wanted to undo that, we would take the square root of both sides, right? These would cancel, but the square root of 16 is not equal to -4. It's equal to 4. So whenever you square a negative, you can't just undo it with the square root sign. That actually brings you down to a different equation. So when we have the square root of x is equal to -4, that has no solution right there. That's different from saying that the square root of -1 is equal to I, right? Not even complex numbers will save us here. There's literally nothing that when you take the square root gives you a negative number. However, when we square both sides, we get x is equal to 16. This right here, if we were to take the square root again, it takes us back down to x is equal to 4, square root of x is equal to 4, not the square root of x is equal to -4. So by squaring a negative, we actually lose information, and we are no longer solving our original equation. Or if we look here, when we square the negative, right, we end up being able to solve for something that goes on this bottom branch, when in reality, we're actually trying to solve for when this top branch hits the bottom line, which is never. So let's look at our original equation again. The square root of x plus 8 minus 6 is equal to x. And something sneaking on the screen right there. So at first, you don't see where the negative is that we're squaring, right? We can add x plus 8 to both sides, and we get that the square root of x plus 8 is equal to x plus 6, right? There's no negative here. But then you need to remember that we need to do this for x is equal to -4 and x is equal to -7. When x is equal to -4, this becomes -4 plus 6, which is equal to 2. And when x is equal to -7, you get -7 plus 6, which is equal to -1, which is a negative. So in the next step here, when we square both sides, we end up squaring a negative, which switches us onto the other branch of the parabola, and we end up getting an extraneous solution. -7 does not solve the equation right here until we square both sides, and that would be x squared plus 12x plus 36. From here on out, though, -7 is a valid solution. But when you go back to the original equation, -7 no longer works, because when you're squaring a negative, you lose information, you hop down onto that second unwanted branch. So that's the visual intuition for where extraneous solutions come from. I hope you enjoyed watching. I had a lot of fun putting this together, and thanks for watching.